Good morning. My name is B. Santhosh Kumar. Today my topic is components of an image processing system. So it is a block diagram of components of an image processing system. So what are the components in the digital image processing? It is also called typical general purpose digital image processing system. Okay. So in this, what are the components are there? What are major components? Image sensors and specialized image processing hardware, computer, image displays, hard copy, mass storage, image processing software. So first, what is the input? Suppose problem domain. What is a problem domain? Suppose some nlog image is there. Okay, we are converting to the soft copy, or we have to change that. So I have to do analog image into the digital image. Example. Okay, so shall we call this is image enhancement or not? Yes, it is a image enhancement. So when we are converting the image from analog to digital, that is I'm calling as image enhancement. So in the total digital image processing, the typical general purpose digital image processing system, what are the major components we need to converting from one image to the another image? So what are the components we need? Suppose problem domain, we have to take some anything of the problem. Suppose I'm taking some analog image. Okay, so image sensors. Image sensors is nothing but it is a physical device. Image sensor is nothing but a physical device. So physical device. Suppose I have to take a picture. I have to take an image. I have to create an image. So what we need? I need a physical device like camera, digital cam, mobile phone. What are the cameras are there in the device? We need that one. So every camera we are calling as that is a sensors are there. Suppose I have the mobile phone, I have to capture one image. Okay, if I have the sensor, then only I will capture the image. Or digital cameras are there. So digital cameras are the image sensors are there. So image sensors are the physical devices to creating the image. Create the image. So image sensors are creating the image. After that, so the image creation is completed from the image sensors with the help of physical device. So after then, what we have to do? Next, specialized image processing hardware. It is a hardware to specializing image processing. So it is creating the image of the. It is a creating the image. So here it is a not a software. It is a hardware software. Hardware already we discussed here. Image processing is a physical device. It is a hardware. But here it is a software. So what is doing here? So the analog image is converting to the digital image with the help of specialized image processing hardware. So it is a hardware to creating the image. It is a hardware, specialized image processing hardware. It is a hardware device which are converting to the soft copy or soft copy of the image. So it is converting to the digital image like this. Next, it is going to the computer. So computer, what is the relation of this hardware to computer? Suppose here image sensors are creating an image. So this creating the image, specialized image processing hardware. This specialized image processing hardware is processing the image, converting to the software. Okay, so soft copy is completed. Here soft copy is there. Soft copy of the image is completed. Okay, that is clear. Next, soft copy is going to the computer. So what is the help of computer? Computer is a ARM like hardwares are there, all the storage memories are there. So computer is for displaying the image. It is helpful to display the image. Image enhancement. Image enhancement means I have to do some modifications in the image. Is it possible? Yes, it is possible. But I need a computer to do the image enhancement or displaying the image. So that is the help of computer. So computer, what is a computer means? Computer in the inbuilt of computer, we have some memories there. image display is there, and we have to use some softwares, or you have to install some softwares, some MATLAB or whatever maybe regarding to the digital image processing. So I have to install the software in the computer only. So after then computer. So what we're doing, computer is displaying the image. Okay, here image sensor is captured one image. So it is converted to the soft copy of the image. Then computer is showing the image with the help of image display. So image display means the image is displaying. Okay, if the image is some blur is there, some noise is there, if anything problem is there in the image display, then it is converting to the hard copy. So hard copy is okay. So hard copy means if the image is okay, if there is no problem in the image, no problem in the image, then it is converting to the hard copy. Suppose we have anything problem in the image, some noise or low brightness, like anything that is there. So it is the computer is converting to the mass storage. So this mass storage is storing the what is the problem of the image. It will be storing the problem image enhancement. It is storing the image. Then it is converting to the image processing software. So image processing software. So it is converting to the reduce the noise, image enhancement process. So image enhancement process will be occurred in the image processing software. Suppose here I'm using one example. I'm using some MATLAB example. So I'm using MATLAB. So with the help of MATLAB, what is the image? Okay, what is the image? What are the noises are there in the image? So I have to increase the brightness or contrast. I have to reduce the noise. How can we know? So image processing software is showing the what is the original image. So what are the intensity values of the image and what are the output images. So I need a black and white to color photo. So some original photo I have to reduce the noise. So I have to increase the brightness. I have to increase the brightness. So contrast. So what it may be. So image processing software will perform all those things. After then it is converted to the mass storage. Mass storage means it is using as an image restoration. Image restoration. So mass storage is nothing but an image restoration. After the performance of image processing software, the output image is converting to the mass storage, then it is going to the computer, then it is going to the image display, then hard copy is converting to the hard copy means analog input, analog image. So hard copy is nothing but an analog image. So a digital image is converted to the analog image. Output is the analog image, or analog image is converted to the digital image, what it may be. But here, what are the needs means? Image sensors I need as an input. Image sensors as an input, but it is a physical device. After then, image sensors are after then specialized image processing hardware. Image processing hardware. So image processing hardware. So here it is the digital image. It is converting to the digital image. Converting to the digital image. Okay. So after then, computer. It will be showing the computer will show the digital image. Okay. Display image. So after then display image converting, it is showing the image. So if I have the no problem means it will going to the hard copy. Hard copy is calling as a analog image. So hard copy is also called analog image. Suppose in the display image I have some noise is there. Some noise is there. So what I can do? So with the help of image processing system, image processing software will perform image enhancement. Will perform image enhancement. So it is performing the image enhancement process, then reduce the noise, then it is going to the image display. Okay, display of the image, then it is going to the hard copy. So hard copy of the image after the modifications, after the reducing this one, hard copy, it is the output. Okay, it is a analog image. So these are the components: image display, computer, mass storage, image processing software, specialized image processing hardware, hard copy, and image sensors. These are the components we need in the digital image processing system. Next, each one we have to discuss. What is one? Image sensor. Okay, it is the first one, image sensor. So, image sensors. There are the two elements are required to acquire digital images. First one, the first is the physical device that is sensitive to the energy radiated by the object we wish to the image sensor. Okay, so it is a physical device. Already we discussed. It is a physical device. Some camera like this. Example is a camera. Okay, or which have the inbuilt of mobile with the inbuilt of camera. Okay, that is, and the sensitive to the energy radiated by the object we wish to the image sensor. So it is a physical device which have the camera is there inbuilt, that is a physical device. And the second called, it is a digitizer, is a device for converting the output of the physical sensing device into the digital form. Suppose example, one person is there, this person is a analog, this person is a analog. Okay, so with the help of sensors, so this person is a input, okay, sensor is a mediator. So then what I'm doing here, so it is the output. So sensor is capturing this person, okay, it is capturing this person, it is this person is capturing. So what is the output? Okay, this output is a digital image. So this is a digital image. So here analog is converting to the digital, analog image is converting to the digital image with the help of sensors. So in this sensors, sensor means it is a camera. So this camera is converting this analog into the digital. Okay, so sensor is showing what is the image, what we captured the image, it will be showing with the in the camera, in the sensors. Okay, so that is the helpful of sensors. So second is a digitizer. Digitizer means the person, I am capturing one person with the help of sensors. So the person is, I am calling as in the form of analog, and I am capturing that one. So analog is converting to the digital image. So that is called a digitizer. So sensor is converting from analog into the digital form, digital image. So analog is a person converting to the image form. So how we are converting the image means with the help of digitizer. So sensors are also called digitizers. So it is also called digitizers. It is a device for converting the output of the physical sensing devices into the digital form. And next one is a second step. First step is sensors are completed. Next, specialized image processing hardware. So what is the hardware? It is the second one. First one we are completed. It is the second one. Okay. So specialized image processing hardware usually consists of the digitizer mentioned before plus hardware that performs other primitive operations such as an arithmetic logic unit which performs arithmetic and logic operations in parallel on entire images. This type of hardware sometimes is called a front end of the subsystem, and its most distinguished characteristics is, in other words, this unit performs functions that requires fast data throughputs that the typical main computer cannot handle. Okay, so what we deeply will discuss here. So specialized image processing hardware. So what is the input for this one? What is the input for this one? So sensors are the input or digitizer. So the sensors or digitizers are the input for this one. So what is the output of this one? So what is the output? So input is a sensors or digitizers. Output is what is the output we are getting. So specialized image processing hardware. It is consisting of the digitizer mentioned before plus hardware that performs other primitive operations such as an arithmetic logic unit. Okay, in the hardware, what we have in the inbuilt of hardware means arithmetic logic unit. So which performs arithmetic and logic operations in parallel on in entire images. So the hardware sometimes is called a front end subsystem. Okay, so this hardware is also called front end subsystem, and its most distinguished characteristics is, in other words, the unit performs functions that require fast data throughputs that the typical main computer cannot handle. So suppose image sensors are captured the image and it is showing to the specialized image processing hardware. So this hardware is showing the digitized image. Okay, it is showing digitized image, but we need storage memory or not? Yes, we need a storage memory. So in this hardware, the image is stored and it will be displaying us. The digitized image is showing for us. Okay, that is one. But we need analog or the arithmetic logic unit we need to perform the arithmetic and logic operations. Okay, and that is the help of specialized image processing hardware. Next, image processing software. So what is the image processing software? It is the third one we are discussing, image processing software. So software for image processing consists of specialized modules that perform specific tasks. A well-designed package also includes the capability for the user to write code that as a minimum utilizes the specialized modules. So image processing software, suppose the input is a digitized. So the input is a digitized image is the input to the image processing software. So what it is performing? The image processing software is performing the input, the digitized image input is the input for the image processing software. So software means, suppose here I am taking some MATLAB example. So MATLAB is useful for digital image processing. Okay, so what is the help of this software? Software for image processing consists of specialized modules that perform specific tasks. A well-designed package also includes the capability for the user to write code that has a minimum utilizing of the specialized modules. So this software, we installed some code or algorithm. So what is the code and algorithm we need for image enhancement? For the image enhancement process, or suppose I have to convert into the black and white to color or noiseless image. So software means it is helpful to converting from black and white to color image or noiseless image or what it may be. So noiseless image. Suppose I have the input image is a noised image. I want a noiseless image. So how can I need? So when I'm using the software, I'm install the code and algorithms. So this software is helpful to remove the noise. It is removing the noise. So the noise is removed in the original image and the output is a noiseless image. Noiseless image. So software is consists of specialized modules that perform specific tasks. A well-designed package also includes the capability for the user to write code that has a minimum utilization of the specialized modules. So what is the image software? Image processing software is helpful. So it is converting the noised image into the noiseless, or color image to the black and white, or black and white image into the color, or increasing the brightness or increasing the contrast, what it may be. So as per our requirement, we have to change from the original image. Okay, that is the help of image processing software. And mass storage capability. Mass storage means it is like a memory. It is like a memory. So mass storage capability is a must in an image processing application, and image of size 1024 into 1024 pixels require 1 megabyte of storage space if the image is not compressed. Digital storage for image processing applications falls into three principal categories. Short-term storage, it is also called during processing. Online storage, relatively fast recall. Archival storage, that is characterized by infrequent access. So mass storage capability. What is a mass storage? Suppose I have the image is there, so I have to store, I have to save that image in a physical device. Okay, it will occupy some space in the physical device. That is called mass storage. Okay, suppose a general example. Suppose I have a digital camera is there. I was captured some images. So the digital camera is converted image, analog image into the digitized image. Okay, the digital image is there. So that camera or that sensors where it was stored. Okay, so in the camera inbuilt we are giving some mass storage capability. We are giving some mass storage, like we are giving some memory space. That one. Okay, in that memory it will be stored. In that memory it will be stored. What it will be stored? The input of the image. What we captured the image, that image is stored in the memory. That is a mass storage capability. Suppose captured image is 10 MB is there. It is one example. Okay, so I want to convert to 1 MB. So 10 MB is stored in mass storage. Okay, it is stored in mass storage. So this 10 MB is converted to the 1 MB. How it is converted? How it is converted? With the help of image compression. Image compression. So image compression is converted this 10 MB into the 1 MB. So after the output of this image, it is the output image. Actually, original image is a 10 MB of the image, but we are converted to the 1 MB with the help of image compression technique. The 1 MB memory is there. 1 MB image is there where it was stored. So we need a memory or not? Yes, I need a memory to store the output image. Okay, so then this output image I am calling as a restoration of the image. Restoration of the image. So restoration of the image. Why I am calling this is a restoration? Sir, original input is a 10 MB. Okay, original image is a 10 MB. I was converted to the 1 MB. How it is means? With the help of image compression, 10 MB is converted to the 1 MB. This 1 MB where we are storing finally mass storage capability. That is the restoration. Where we are storing in the place of input image. So in the place of input image, I am storing this output image. So in the place of input image means 10 MB is there, but I was changed to 1 MB. So 10 MB where it is stored, in which place it was stored. In this place, I am changing the in 1 MB is changed. This is the restoration of the image. So 10 MB is changed to the 1 MB. That is the image restoration. So 10 MB is converted to the 1 MB. So finally, what is output means? 1 MB is a final output. So it is a image restoration. So 10 MB I don't need. I no need. Why? Because I no need of 10 MB. Okay, I need only 1 MB. So finally, I am removing this space, and in this place 1 MB I am storing. In the place of 10 MB I am storing 1 MB. That is called image restoration. So in the input I need 1 memory. In the output I need 1 memory. So mass storage capability is replacing with that one. And what is the size of the image? It is a 1024 into 1024 pixels required, or 1 megabyte of the storage space is needed for the memory mass storage capability. So Mass storage capability is a must in image processing applications, and image of size to 1024 into 1024 pixels requires 1 megabyte of storage space if the image is not compressed. Next, what is the digital storage for image processing applications? So what are the applications for the digital storage of the application? I have the memory storage capabilities there. I was stored image, but what are the applications? Why I'm using memory storage? Okay, so what are the applications? So it is the short-term storage or during processing. Suppose input is at 10 MB is there, already we know that now. So 10 MB is replaced with 1 MB. So 10 MB is a short term storage or not? Yes, it is a short term. Why? Because after the converting image compression, what is the final output? After the image compression, what is the final output? I am replacing with that one. Originally is replaced with output image. So this 10 MB is replaced with 1 MB. So it is called short term storage. Means during the process, during the image compression. I no need permanently. When I'm converting from one image to the another image, when I'm converting to the image compression technique. During the image compression technique only, I need input image. After the getting the output image, I don't need of any input image. Suppose I have the image is a noise image. Okay, I was converted to the noiseless. So noiseless output is came. But what is the need of noise image? So I'm removing the noise image. So that is called short-term storage. Short-term storage means noise image is temporarily using. When after getting the noiseless image, I no need of noise image. Okay, that is the noiseless image. That is a short-term storage capability. And online storage, that is a relatively fast recall. Means online storage means I'm not storing in my physical device. I'm not storing in any of the memory card or memory storage or any phone or any camera. I'm not using. Okay, if I'm not physically, I'm not using. Okay, online means suppose I have to put in a social media. Example, I have to put in some mails in the inbox or whatever maybe. Okay, I have to storage in the drives. Okay, these are the I have to store in the Facebooks. So these are the soft online or online storage. No need of physical device. Okay, big data computing like, and archival storage characterized by infrequent access. Archival storage. Okay, we have to storage in one archival storage. It is a characterized by infrequent access. Infrequent access means permanently we are not using. Some randomly I'm using. I'm not permanently I need it. So it is a infrequent access or archival storage. Okay. So short-term storage means I need a physical memory. But online storage means we need a physical memory, but in our device. No need of any of the physical device. No need for us. Okay. That is the online storage of the relatively fast recall. Next, another type of mass storage capability is there. It is a one method of providing short-term storage is computer memory. Another is by specialized boards called frame buffers that store one or more image and can be accessed rapidly. So, short-term memory. So, what are the examples of short-term memory? So, short-term memory is one of the another one is a storage in computer memory. So storage in computer memory, storage in phone in the phone memory, storage in one memory card. So this is one short-term memory. Another is by specialized boards called frame buffers. These are the stores one or more images and can be accessed rapidly. These are the short-term memories, short-term images storing. And online storage method allows virtually instantaneous images, some zoom as well as scrolling, vertical shift, pan, horizontal shift. Online storage generally takes the form of magnetic disk, means floppies, pen drives like this, and optical media storage. The key factor characterized online storage is frequent access to the stored data. So these are the online storages. And finally, archival storage is characterized by massive store requirements but infrequent need for access. So what is the archival storage? It is a characterized by massive storage requirement but infrequent need for access. This is the archival storage of the memory. So how many types of memories are there in the mass memory storage? Means three types are there: short-term storage, online storage, archival storage. and another one is a image display. So image display means after getting the computer, so computer is showing that one, so it is the input, computer is the input for the image display. So image display in use today are mainly color, preferably flat screen. So I have the image is there, okay, I want to display. What is the need of to display the image means, what are the to finding the colors, background colors or person color or items colors, whatever may be, to finding out the colors of the item. And TV monitors, examples are the image displays are the TV monitors are the good one, and monitors are driven by the outputs of the image and the graphic displays cards that are an integral part of a computer system. So suppose I have a TV is there to display the image. Computer also one of the display of the image. So two monitors are driven by the outputs of the image and the graphics display cards that are an integral part of a computer. Suppose I have a computer to display image. So I have a computer to display the image. So how we are displaying? Only computer we need? No, I need a memory. So in the memory, images are stored. So images are stored in the memory. Memory is connected to the computer. Computer is showing the display images. Okay. So in the background, what is the work is going on in the before the image display means, so TV is there, it is showing the image, but how the TV is showing, so we need some memory to connect into the TV, then only TV showing the images. So mass storage is very important to show the image or imaging displays. Okay, best example is a TV or computer to showing the images, but we need definitely memory card or storage memory is needed to showing the image. And hard copy devices. So hard copy devices, what are the hard copy devices? Used for recording images include laser printer, film cameras, heat sensitive devices, inkjet units, and digital units such as optical and CD-ROM discs. So hard copy is there. So I have hard copy means what are the requirements we need, what are the devices we need to getting the hard copy. Hard copy is nothing but an analog image. So it is a analog image. So hard copies need analog image. The output is an analog image. But what are the devices? What are the requirements we need to getting the hard copy of the image? Means it is the laser printer or film cameras, all those things we need. Suppose I have a printer. I have a laser printer is there. So how we are getting the printer output? So printer is there. Printer is a median to getting the output. So printer is one of the median to getting the output of the image. But what is the input? How it will give the print? So what is the source? So what is the input to the printer? So input to the printer is a one CD-ROM or some memories or whatever maybe. So recording of the images, CD-ROM discs, inkjet units, digital units, optical and CD-ROM. So these are the sources to the hard copy or sources to the input. So input image, then printer, then output. So input image is a digital image, output image is a analog image. So between the input and output, what is happening? Digital image is converting to the analog image. But how it is going on? So digital image means where I am capturing. Digital image, what is the source of the digital image? So digital image means recording of the images or CD-ROM disk or optical memory or heat sensitive devices. These are the inputs to the digital image. Okay, it is creating the image in the form of digital and it will give the source, it will give the input to the printer. Okay, this soft copy of the digital image is giving the input to the printer. So printer is capturing the digital image and it will give the output as a analog form. That is called hard copy of the device. Next, networking. It is the most important in the components of image processing system. So networking is almost a difficult or default function in any computer system in use today because of the large amount of data inherent in image processing applications. The key considerations in image transmission is bandwidth. In the dedicated networks, this typically is not a problem but communicates with remote sites via the internet or not in always an efficient. Okay, not always efficient the networking, but it is a major role in the storing the data. Suppose I have the digital image is there. So digital image is there. I want to transmitting this digital image to the another device. Okay. So I want to convert one image into the another image, one device to the another device through transmission process. Okay. It is a default function in any of the computer system in today because of the large amount of data inherent in image processing applications. The key consideration of the image transmission is bandwidth. If the dedicated network, this typical is not a problem in a communications, but in the remote sites via the internet are not always as efficient. Okay, suppose in my mobile phone I have an image is there. I want to send it to another source or another camera or another mobile phone. So how I'm transferring? So with the help of networking or internet or through the website, I'm transferring one image into the another image. Suppose example I'm using one email. Okay, I want to send my image into my friend or any other person. Okay, so if we need any social media, as I need some website. So networking has a major role to converting to the one image of the source into the another source. So one device to the another device through the transmission process. It is a networking. And so these are the components of an image processing system. So what are the components means? So what are the components we need? Suppose problem domain, image sensors, specialized image processing hardware, image processing software, computer, image display, mass storage, hard copy. These are the major roles. These are the components of an image processing system to convert into the analog image into the digital image or digital image into the analog image. Another one is a fundamental steps in digital image processing. So previously we discussed what are the components I need, but here what are the fundamental steps to convert it to the analog image into the digital image or digital image into the analog image or image enhancement or image restoration, what it may be. So what are the steps? What are the fundamental steps in digital image processing technique? So these are the fundamental steps. First one is a image acquisition, image enhancement, image restoration, color image processing or wavelet and multi-resolution processing, image compression, morphological processing, segmentation, image object recognition and representation and description. So these are the 10 are there, total 10 are there. These are the fundamental steps, total 10 stages are there. These are the very major role, very important in the digital image processing. So image acquisition. Image acquisition means suppose I have the image is there. That image I want to show in the digital form. I want to show in the pixels. Okay. So when I am applying the zoom, okay, it is showing as a pixels. So how many pixels are there in this image? Suppose 1026 into 1026 pixels are there. So how we need it will be going as a 1026 into 1026. When the pixels are showing in the image, then that is called, it is a digital image. When the image is showing as a pixels, then it is a digital image. So image acquisition means one form of image is showing is in the another form of image. Okay, I want to compressing the image. I want to reduce the image size. So size I have to increase or size I have to decrease. Okay, so 10 MB of the memory is converted to the 1 MB. So is it possible? Yes, image compression. Image compression is performing. So what is the input source? That is the image acquisition. It is the input source. Suppose I need an image. Okay. So what is the source of the input? Image acquisition is called the source of the image. That is the input image. Okay. So input image is showing as a in the form of pixels. Next, image acquisition. It is a modalities for getting the image into the computer. The image is captured by a sensor. Example, camera. Okay. In the previously we discussed sensor is nothing but a camera. Example. And digitized if the output of the camera or sensor is not already in digital form using LLR to digital converter. So it is a LLR form. I am converting to the digital form. How I know it is a digital? These are the pixels. If the pixels are showing, pixels are displaying in that is called, it is in the form of digital. So image acquisition is converted to the LLR form into the digital form. How I am converted? With the help of sensors or with the help of camera, I was converted from analog form to the digital form. So the modalities for getting the image into the computer, the image is captured by a sensor or camera and digitized if the output of the camera or sensor is not already in digital form using analog to digital converter. Next, image enhancement. So image enhancement means, suppose it is the input image and it is the output image. So what is the difference? Input to output, what is the difference? Means input is some brightness is increased. More brightness is there. That is the reason I am not identifying the image. Okay, it is not clarity is there. Okay, why? Because the brightness is high. So I am decreasing the brightness. I was decreased the brightness. So after reducing the brightness, it is a normal image. So what is the input image? It means noisy image, or what is a noisy? Brightness is very high. So I want to convert it to the normal image or converted to the normal brightness of the image. So how it is going on? So when input to the output, the process is going on. That process I am calling as an image enhancement. Image enhancement means it is performing one form of image to the another form. What is the first form? It is a noisy. Output is a noiseless. So one form to the another form. That is a image enhancement. So it is a process of manipulating an image so that the result is more suitable than the original for specific applications. The idea behind enhancement technique is to bring out details that are hidden or simple, or to highlight certain features of interest in an image. Okay, it is converting one form of to the another form of noiseless to the noisy or noisy to the noiseless, what it may be. That is the image enhancement. It is a behind of the image enhancement technique to bring out the details that are hidden or simple to highlight certain features of the interest if an image. Okay. Next one is a image restoration. Okay, the first input I was stored in one memory. Okay, after getting this output, it is the output of the image. Okay, so this first input is a brightness is very high. So noisy image is there. I was converted to the noiseless. So noiseless image. This output I want to store. This I want image I want to store. Storage in memory. So what is the first input? I no need of this one. Okay, I removing the memory. Memory no need. Why? Because it is a noisy image. It is a noisy image. I no need to store this one. Okay, in this place I am output. What is the output? Noiseless image. So this noiseless image I was stored in that one. So that is called storage in memory. That is called image restoration. Image restoration. First image is there. That is the storing of the image. But output is no need of input. Why? Because first input is a noisy image. I was converted to the noiseless image. So I no need of to require to store in the for the original image. Okay, original image I was removed from the memory, and output image, noiseless image, I was stored in the first input image. That is called image restoration. So image restoration is that output image is replaced with input image is replaced with output image. That is the image restoration. So image restoration is improving the appearance of an image, and is tend to be mathematical or probabilistic models, and enhancement on the other hand is based on the human subjective preference regarding what consists of good enhancement results. Next one is a morphological processing. So morphological processing is completely, it is a extracting of an image processing and a representation and a description of the shape, and it would be transition from process. The output of the image is the output of the image attributes. Okay, it is completely for fingerprints or thumb. Okay, it is a fingerprint or thumb. So it is a brightness is very low. I was converted to the brightness is very high. Okay, only for thumb impression or fingerprints applications we are using morphological processing. Next one is a segmentation. So segmentation means, suppose it is the input image is there. So what is the input image? I'm converting to the segments. So how many black colors are there? How many white are there? Suppose here it is one black, it is one black, it is black. So these are the whitish are there. So segmentation means it will convert into the segments. Okay, how many black colors are there? How many white are there? So what is the intensity of the images? That is a segmentations. So segmentation process is a partition of an image into a constituent parts of an image. So what is the important tip for segmentation? Means the more accurate the segmentation, the more likely recognition is to succeed. Suppose I have the image with more accurate. So I'm more accurate segmenting the image, more likely recognizing of the succeeded. Suppose I have the more accurate of the image. Image accuracy is very high. It is easy to segment the image. Okay, that is one. Another one is a image recognition. So how we are recognizing in this image? How we are recognizing? Suppose there are so many vehicles are there on the road. So it is one van, it is a car, and it is a bus. So how we are recognizing? Okay, we are giving some different identification processes or to identify the images. That is a object recognition. Next one is a representation and description. Suppose one image is there. What is the representation of that image? So suppose one person or one animal. Okay, person with eyes, person with hands, person with some legs. So we are representing a image, and it is showing as a what is the representation of the image, and it is giving the description of that image. That is the representation and description of the image. So how we are representing and describing? So it is a make a decision whether the data should be represented as a boundary or as a complete region. It is almost always follow the output of a segmenting storage. So image segments already we discussed that in image segmentation stage we are representing as a what is the image representing in the with the help of image segmentation we are representing what is the image and what is the description of the image. And boundary representation focus on external shape characteristics such as corners and inflections. These are the boundary representations. And region representations focus on internal properties such as texture or skeleton shape or whatever may be. So I have the input image is there. I want to more focus on what is in the image. What we have to more concentrating on the internal properties of textures or skeleton shapes of the image. That is the region representation. So every image we have to give some representing, and we are giving some description of the image. That is the important. So here in the above figure, transforming raw data into a form of suitable for subsequent computer processing. Description deals with the extracting attributes that results in some quantity information of the interest or as basic for differentiating or one class object from another. So one class object is converted to the another form of object. Okay, how it means we are recognizing and representing the image. Another one is a image compression. Already we discussed. So 10 MB of the image is converting to the 1 MB. Is it possible? Yes, it is possible with the image compression. Okay, image is compressed means we are reducing the size of the image or reducing the pixel size. Then only size will be decreased. Then image compression is going on. But what we need? I need a software. I need a software to reducing the size of the image or reducing the pixels of the image or compressing the image. So technique for reducing the store required to save an image and the bandwidth required to transmit it. So I need to store. Yes, the input is there now. Input is there. Where it was stored in the memory after the image compression. Image compression is completed. So what is output? So compressed image. Output is a compressed image. So compressed image, where it was stored compressed image, it was stored in a memory. So definitely we need a memory. So it is a technique for reducing the storage required to save an image or bandwidth required to the transmit. So reducing the storage. Why? Because 10 MB is stored is converted to the 1 MB. So shall I reduce the size or the is there? Yes, I reduced the image size. Okay, it is a technique to reduce the image size and reducing the storage capability of the image. The last one is a color image processing. Suppose in the input image we are not identifying the colors. Okay, so what are the unidentified colors are there? We are applying those colors to the original image, and after getting that one, output is a colored output. Okay, it is a noisy image. So noisy image. So that is the reason we are not identifying the original image. Original colors are damaged due to the noise. Okay, so we are applied some colors to that one. So what are the output image is a noiseless output. So it is only for the color image processing, not for black and white. So color image is used to the color of the image to extract the features of interest in an image, color modeling and processing in a digital domain process. So these are the color image processing. And step 10, last one is a multi-resolution analysis using wavelets. So these are the foundation of representing images in various degrees of resolution. It is used for image data compression, where images are subdivided into smaller regions. And multi-resolution analysis is a different approach of signal processing that gives coarse as well as detailed information at the same time. So when MRI scan or any resolve signals are there, so we are transforming the original image. So we are transferring. So wavelet transform. So here wavelet transform gives more information than Fourier transform and also computationally efficient. We are using some transformation techniques to getting the original image to the output of the image. Applying the wavelet transform or Fourier transform or different types of transportation techniques we are using to getting the output image. So these are the fundamental steps in digital image processing: image acquisition, image enhancement, image restoration, morphological processing, segmentation, object recognition, representation and description, image compression, color image processing. These are the fundamental steps in digital image processing. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.